Okay, guys, welcome to my class once again, and thank you for joining me. Today, I have valency and oxidation state. I want us to quickly look into the relationship between valency and oxidation state. And the question one we ask is, what is valency? Please, valency is different from valence electrons. Valency is the combining power of elements, while the valence electrons are the number of electrons in the atmospheres of the element. So if you have gotten or if you have known what a valency is, it is very easy for us to place oxidation state of ions. If we have our valency, all we need to do is to place either a positive or a negative charge on the valency of that electrons to get the oxidation state. For example, metals have oxidation state or positive oxidation state because of the ability to give or to lose electrons. While non-metals gains electrons, therefore they have a negative oxidation state. So if such is the case, let us demonstrate some of the valencies and oxidation state of ions of this very particular element. It will be very quick and simple. Okay, the first element we have here is chlorine. We all know that chlorine has atomic number of 17. Chlorine has atomic number of 17. That is 287. Now, this 7 is the valence electrons of chlorine, but the valency here is 8 minus n, where n represents the number of electrons in the atmosphere. We are going to have 8 minus 7. So we are having chlorine is 1. And because of this 1, which means that the valency of chlorine here is 1. And if you have gotten the valency of chlorine, it is very easy to get the oxidation state of chlorine. This is the combining power of chlorine, because chlorine will always need one electron to attain the octet state or to be stable. Okay, so if such is the case, it simply means that because chlorine is a non-metal, its oxidation state of its ion becomes -1. Okay, 1 minus 1, because chlorine is a non-metal. We have the second element, aluminium. Aluminium is 13, 2, 8, 3. Elements that have 1, 2, 3 electrons in the atmospheres are metals. Okay, so aluminium is a metal. It has 3 electrons in its atmosphere, which is 3 electrons there is the valence electrons, and also 3 electrons there is also the valency in this case. The 3 electrons in the atmosphere is the valence electrons of aluminium and is also the valency of aluminium. So aluminium has 3 as its valency. To get the oxidation state of aluminium ion is to place either a positive or a negative charge on the valency. So because aluminium is a metal which can easily donate 3 electrons, its oxidation state of the ion becomes +3. We have oxygen. Oxygen has a valency of 2. Oxygen is 2 and 6, which is 8 atomic number. So 6 is the valence electrons, while the combining power of oxygen is 8 minus 6, which is 2, which is 8 minus 6 for oxygen, which is 2. So now oxygen is a non-metal. So for the fact that oxygen is a non-metal, please let me use my. So for the fact that oxygen is a non-metal, oxygen has -2. Here, copper. We have some elements that have variable oxidation state. Here, copper has variable oxidation state. So copper will have either 1 or 2. Copper 2 or copper 1 ion, okay, as the case may be. So because copper is a metal, copper will have a oxidation state of its ion will be either +1 or +2. Okay, we have tin. Tin is 4. Tin has the valency of 4. So because of tin is a metal, tin has +4. Then we have lead. Lead has variable oxidation state. That is why sometimes you can hear lead 2 oxide or you can hear lead 4 bromide. So lead can exist as either lead 2 or 4. So because of this fact, lead is a metal, so the oxidation state of lead can be +2 or +4. So these elements with variable oxidation state will help you in the IUPAC nomenclature of their ions. So look is the combining power of an element, while oxidation state here or number here is the charge on the valency. Thank you for watching and see you in my next class.